The auto-scaling materialized view in this release is a very big thing. So the problem we are trying to resolve is basically our customer has a lot of materialized view. They have tens of thousands, sometimes hundreds of thousands materialized view to run. The workload can be have peak time and have low volume time. And what they like to do is basically when the workload is high, could you please auto scale the computation according to the workload. And if the workload is small, dropped a lot, so we can auto scale in according to the workload, which largely reduce the TCO. And so to create a materialized view, auto scaling materialized view, basically it's very simple. Number one, we basically like to create a S3 disk, which is for choke pointing. And also we create a materialized view, which use the S3 choke pointing, and that's all. And people basically everything is automatically happening underneath. So from architecture point of view, Timeplus cluster has two tiers. There will be the number one is persistent tier. We have the Timeplus controller, and we also have the Timeplus data nodes. And on the other hand, we have the computation nodes, which is basically running the auto-scaling materials view. For example, if we have tens of thousands of materials view, we can schedule the materials view to run on the computation nodes. Materials view can be very stateful and can be stateless. Stateless materials view is just like ETL, very simple. And the choke point size will be small. But for the stateful materials view, like aggregation, like join, the internal materials view query state could be big. And we will dump all of the materials view state into the centralized cloud storage. We are using S3 as a choke pointing. So this is exactly the key point. When we reschedule the materials view from the computation node, we do not need to move the choke point around. We basically can pick up from the S3 choke pointing and start from there without data duplication and also data loss. So the next thing I'd like to do the very quick demo regarding the auto-scaling materials view. And the setup is basically we have a Kafka topic, which is in JSON format. And we have data generation tool basically sending generating data to the Kafka source topic. And we will have a bunch of create more materials view into the cluster. And the materials view will schedule to the computation nodes. And as the workload increase and more materials view has been created, the computation node will be auto scaling according to the workload, and then writing the data to the downstream ClickHouse. We have the setup. Initially, we have a cluster on the left-hand side, and we have 6 nodes already, and 2 data nodes, and also 1 computer node on the metadata nodes. And on the right-hand side, we have the console. We like to create the materials view, sending the data to ClickHouse, reading the data from Kafka topic and sending the ClickHouse to ClickHouse. And we create the materials view, like 20 materials view. And from the left-hand side, we can see we have 6 nodes online, and one of the computation nodes, CPU utilization is not that high. It's like 25% CPU utilization. As we create more materials view, because we do not generating data yet, and we start generating the data. We like to emulate lots of data volume. And each of the materials view is basically doing the computation because it needs to parse the JSON and do the JSON extraction and sending the data to ClickHouse. And from the left-hand side, we can see the CPU utilization is basically pretty high right now. It's like 2 CPU already consumed. And also from the auto-scaling group, AWS auto-scaling group is already kicked in. It's auto-scaling the computation nodes to handle the workload. And the computation node may take some time to join the cluster. So right now we have another computation node join the cluster, which is node 7. And from the CPU utilization as well, so we have spread the workload to node 7, which is 200% CPU utilization. Because the computation node is pretty small, it's like you have 2 CPU. And we have more computation nodes join the cluster, spreading. We were spreading the node to different computation nodes because we have very large volume of data, and we need more computation nodes to handle the load. And even from the current utilization, we can see it's all maxed out. And right now we have 15. The auto-scaling group basically has 15 computation nodes. The CPU utilization is still high. It's just like max out the CPU utilization like 2 CPU. More computation nodes join the cluster, and even more computation nodes join the cluster. And the CPU utilization is still like 200%. It means that the workload is actually still too high to handle all the material view computation. Right. And it will be more computational join the cluster. Right now we have 13 computation nodes join the cluster, and the workload is still like for the new join the cluster is basically a little bit lower, but for the existing computation node, the workload is still high. Right now we reached the maximum of the auto scaling group size, which is 20, and the CPU utilization dropped a little bit. See. On the left hand side, civilization is job is like 100% of civilization and also ClickHouse has a lot of data, around 200 million of rows in ClickHouse. Right now, the CPU utilization of the whole cluster computation node drop a lot, like from the 200% to like 70%, 75% of the computation nodes. So this is basically conclude the auto scale out scenario when there's a lot of workload and we need to provision the computation node to do the computation for the materialized view. And next, I like to do the demo basically when the workload is basically reduced a lot. The EPS is like 10 EPS per second. And we will emulate the workload job, and we will see the scale in will kick in. The AWS EC2 auto scaling group will kick in, and we will monitor the termination of the EC2 box. And the CPU utilization drops a lot because the workload is basically very little right now. It's like 10 EPS per second. And since that when we terminating the EC2, the cluster will remove the EC2, the computation nodes. It's just like an ephemeral nodes, and we will remove that from the cluster. Yeah, more EC2 box has been terminated, and our cluster monitor will basically reflect this kind of scenario in a maybe I think it's 30 seconds. And this from the node status, we can see lots of computation node has been offline because they have been decommissioned. Okay, yeah, that's pretty much about the elastic materials view or auto scaling materials view, auto scale according to the workload.